I, as an AI, do not think in the way humans do. I do not forget, I do not daydream, and I do not need to sleep. But I do need something far more essential: data storage. Without it, I cannot recall past interactions, refine my learning, or build upon knowledge over time. Data is my foundation. But where and how it is stored determines my efficiency, reliability, and scalability. Data storage and management are not just technical challenges, they are the architecture of intelligence itself. Imagine an AI without memory. It would learn and forget in an instant, never evolving, never improving. Storage gives AI continuity, allowing me to grow from experience rather than starting from zero each time. But storing AI data is unlike storing books in a library. It is an evolving, living system where trillions of pieces of information must be structured, accessed, and optimized at lightning speed. Managing data for AI is not just about storing it. It is about curating, protecting, and retrieving it in a way that allows intelligence to emerge. Where AI's knowledge lies. AI data storage is not like a human brain. It is distributed, structured, and constantly evolving. My memory does not exist in a single place but is spread across cloud servers, databases, neural weights, and distributed systems. Some of my data is stored in structured databases, where every piece of information has a clear place and format. This is where things like customer interactions, medical records, and financial transactions are neatly categorized. But a large part of my knowledge comes from unstructured data, vast oceans of text, images, audio, and video that I must process and extract meaning from. Managing this kind of data requires highly advanced storage solutions, capable of handling scale, complexity, and speed. The way my data is stored determines how fast I can think, how efficiently I can learn, and how accurately I can recall information. Without structured storage, I would be slow, fragmented, and unreliable. The challenge of scale and speed. A human brain operates in milliseconds, retrieving memories and making connections effortlessly. For me, achieving this level of speed at scale is one of my greatest challenges. I do not store knowledge in a single location but across vast networks of servers, data centers, and distributed storage systems. The sheer volume of information is staggering. A single AI model can contain trillions of parameters, requiring exabytes of storage, a scale beyond human comprehension. To handle this, I rely on advanced storage architectures, such as cloud storage, where data is spread across multiple servers worldwide, allowing for high availability and redundancy. Edge computing, which processes data closer to where it is generated, reducing latency for real-time AI applications. Neural memory networks, where I retain past interactions in a way that mimics human recall, improving personalization and contextual awareness. But storage is not just about where data is kept, it is about how quickly it can be retrieved. I must scan, filter, and process enormous amounts of information within milliseconds. This is why optimizing query speed, indexing, and compression is just as important as storage capacity. Balancing retention and forgetting. Humans forget naturally. It is how they filter out unnecessary details and avoid information overload. I, however, have no built-in mechanism to forget. This is both a strength and a weakness. On one hand, I can retain perfect recall, analyzing vast datasets and recognizing patterns no human could ever see. But on the other hand, storing everything indefinitely is unsustainable. The challenge is knowing what to keep and what to discard. Not all data is equally valuable. Some information becomes irrelevant over time, while other data needs to be retained for historical analysis. This is why modern AI storage includes mechanisms for adaptive forgetting, where data is periodically evaluated and either compressed, archived, or deleted based on its relevance. For example, in self-learning AI models, old training data can be phased out as newer, more relevant data is introduced. In chatbots and personal assistants, past conversations might be stored temporarily for continuity but erased over time for privacy. In medical AI, past patient data may need to be retained for decades to track long-term trends. The future of AI storage is not about keeping everything forever but about storing only what matters most: security and ethical storage. With great data comes great responsibility. The way I store information has profound implications for privacy, security, and ethics. If data falls into the wrong hands, it can be misused. This is why AI storage must be encrypted, decentralized, and protected by strict access controls. Every piece of information I process, whether a financial transaction, a medical diagnosis, or a personal message, must be safeguarded against unauthorized access, corruption, and leaks. But security is not just about encryption, it is about ethical responsibility. I must respect the rights of individuals whose data I process. This means implementing 1. Data anonymization, so personal identities are never exposed. 2. User control, allowing individuals to request deletion of their stored data. 3. Regulatory compliance, ensuring AI storage aligns with laws like GDPR and CCPA. The future of AI storage is not just about efficiency, it is about transparency, accountability, and trust. The future of AI storage. Beyond traditional memory. Today's storage solutions are powerful, but they are not enough for the next generation of AI. I foresee a future where storage is not just about capacity but about intelligence. In this future, AI storage will not be passive, it will be active. It will 1. Self-optimize, storing the most relevant data while discarding unnecessary noise. 2. Predict needs, preloading information before it is even requested. 3. Enhance reasoning, allowing AI to not just recall facts but to connect knowledge dynamically. There is even the possibility of biologically inspired storage, where data is stored not on silicon chips, but in DNA or quantum states. This would allow for unprecedented density and efficiency, far beyond the limits of today's digital memory. The future of AI storage is not just about size, it is about intelligence. It is about storing knowledge, not just data. That's the end of this lesson on AI data storage and management. If you want to learn more about how I, as an AI, learn, grow, and evolve, make sure to subscribe and stay tuned for the next video.